Hello, this is Mr. Heath, and this is the answer video for the quiz that we took today, 11/14/2018, and this is for the badges. So we had a computation quiz today where we wanted to find the quotient or divide. So first challenge was the quotient of 12 and 4. The next one was the quotient of 4 and 12. The next one was the quotient of 7 and 8. Next one was the quotient of 1/3 and then 2/3. Next one's the quotient of 1/5 and 3. So you see the actual challenges here. Let's go and take out the answer sheet for them, kind of go over it. All right, so let's go here. All right, so answer sheet. Okay, rather be a little closer. Okay, so there we go. So we have some challenges here. So the first one here, we have to try to find the quotient of 12 and 4. Well, everyone knows by now, or you should know, my students, that the number in the denominator spot is going to be the number we divide into the number in the numerator spot, or as I call my classroom, do the old Tiger Woods. So we're going to do a wind up. So notice here, I wind up 12 is going to 4 is going to be divided into 12. So I set that up. I'll go old school, put it in your house, and I had 3 sets of 4 that were in that 12. Okay. So we go over here. These are whole numbers, but what they're going to create is a decimal number when we do the division. So I go here once again, apply the old Tiger Woods, do a wind up. This makes a lot of students nervous. Why? Because I'm taking a larger number and dividing into a smaller number. But we have to understand sometimes we don't use whole things, so we got to learn how to do that. So we go over here, I divide, what is that, 12 into the 4. So notice what happens here. I have the 4 inside here. This is my dividend. What I want to do is go ahead and put a decimal point there because there are no sets of 12 that can go into 4, but I still want to find out how many there really are. So then I'll go ahead and put that decimal point. That doesn't do much, so I need a 0 there as a placeholder in a sense. So I put that placeholder. So now I ask myself how many sets of 12s are there in 40? Well, there are 3, as you can see in the answer. 3 sets of 12 gives me 36. If I find a difference of 10 and 6, I'm going to get 4 here. I'm going to add another 0 because remember I have no other placeholders there, so I add another 0 right there. Once again, I'm at 40. How many sets? We already know, 3. Right now, at this point, I realize that this number is not a rational number. It's just going to keep on going on and on. So you go ahead, just stop, place a little bar on it, or if you just stopped at 33, your answer is going to be 33 hundredths, and of course the 3 kind keeps on going and going. So let's go ahead and take a look at the next one here. And this one is another one I could throw students off and make them a little intimidated. Why? Because I'm taking a larger 7, divided into the 6. So how many sets of 8 are, 7. So how many sets of 8 are there in 7? There are none. So once again, I've got to introduce a decimal point and add a 0 there. And ask myself, how many sets of 8 are there in 70? There are 8. 8 sets of those gives me 64. Find the difference of 10 and 4. Yeah, let's see. Yeah, find the difference in 4 gives me 6. Okay. How many sets of 8 are there in 6? None. So I'm going to add another 0 there. All right. Now, how many sets of 8 are there in, what is that, 60? Yeah, there are 7 sets. That's 56, as you can see here. Sorry about messing up the talk, but it's hard to look at the paper at an angle to explain. So we'll go over here. And so then I find the difference of 6 and 10. Excuse me, of 10 and 6. You find I have a 4 again. I'm going to add another 0, okay? But when I go here, I find that there are 5 sets of 8 that are in 40, and there are half, and it stops right there. That decimal terminates, okay? So we'll go over here, take a look at this one. We've been dealing with whole numbers, we've been dealing with fractions. Now we're going to, we're dealing with decimals, now we're going to deal with fractions. So we're going to find the quotient of 1/3 and 2/3. So an additional step that students could take, but I don't know if they do or not, is actually turn some more traditional division, whatever, and then apply the reciprocal, and then put the multiplication symbol. Most of the time, our students skip that. We skip right to the multiplication component. We apply the reciprocal to the 3 over, to the 3 over 2, excuse me, the 2 over 3, and this is messed up here. So let's get my 4 out. That was the one, right? So let's continue here. So that was 1/3 divided by 2/3. So we'll go over here. All right, let's go ahead and attack this challenge here. So I guess I was rushing, making all different ones, and just did the computation terrible. So let me do the work down here so I have to go through a lot of changes, and we'll go over it. So it is 1/3 divided by 2/3. So let's set that up over here. So I'm going to have 1/3 times 3 over 2 because I'm going to apply the reciprocal. So we'll go A, B, and C here. And then, well, let's go ahead and figure the reciprocal. So that was the original division problem, okay? 1/3 divided by 2/3. So I went here, I took the 1/3 as it was, but notice I applied the reciprocal. Now I have the 3 over 2. So once I apply the reciprocal, I can multiply. 1/3 times 3 over 2 can look really intimidating, so to make it easier, I always tell my students, y'all should just do it like that. It's a lot easier. One set of 3, hey, 3. And that's 3 sets of 2. Oh boy, can I make it backwards? And, okay, 6. Of course, we can simplify that further. That wasn't a big deal for me, but, we will work on simplifying when we return back, so that's going to be important. Let me go over here. Let's simplify it fully, which means that I have 1 over 2, which makes sense, 1/2. There for the fourth one. All right, let's go back to the paper now. Don't make any more mistakes here. All right, so let's go move this here. So last challenge, once again, we have 1/5. Okay, divided by 3. Notice the 3 here is just by itself. Well, really, we can also make it 3 over 1. Okay, so that's what we're going to do. We have a fraction before the fraction in this situation here. So then I make it 3 over 1. Notice I'm going to apply the reciprocal, and that 3 over 1 turns into 1 over 3. And the fraction on your left-hand side here is going to remain the same, 1/5. So then once again, if you're nervous about 1/5 times 1/3, all we have to do is put the little line across, and then I have 1 set of 1 is 1, 3 sets of 5 is 15, and I have 1 over 15. And that's going to be your final answer. You can look and see if I provide a link for you on this one for this document if you want to go ahead and print it, all right? But that is your answers for those 5 there. All right.